So, welcome to today's lecture on vapor compression system. So, today I am going to solve two problems, and I am sure that if you understand those two problems, then you will be able to solve any kind of problems regarding vapor compression. Okay, first let me tell you about these four processes. Just a quick recapitulation. First is evaporation. It is the process that is taking place in the evaporator. Here the liquid refrigerant is taking the heat from the foodstuffs that you keep, and after taking that keep, it is becoming vapor. Okay, and then in after from the exit from the evaporator, it is going to compressor for isentropic compression. Isentropic compression means entropy is constant. Entropy is constant. Practically entropy is not constant, but for the sake of simplicity and for doing problems, we consider that entropy is constant. Okay, then is condensing. After compression, the liquid refrigerator needs to be condensed. Okay, liquid refrigerator needs to be condensed. It happens in a condenser. Condenser is nothing but a type of heat exchanger. Here the liquid refrigerant leaves the heat to the ambient. In the back of your domestic refrigerator, if you see that there are some coils like this, there are some coils like this. This is through these coils the the refrigerant is flowing. The refrigerant is flowing, and if you stand behind those, if you stand near those coils, um, you will feel that your body is getting heated up. Why? Because these coils are leaving heat, because the refrigerant that is passing through these coils is now condensing. Condensing means what? It is now leaving heat. Okay, so after leaving heat, it comes back to its liquid state, and it goes to throttle valve for throttling process. And throttling process is nothing but isenthalpic expansion. Isenthalpic expansion means enthalpy is constant. H is constant. Okay, and in isentropic compression, your S is constant. Okay, now let me just tell you about the pH diagram and TS diagrams, then we will solve the problem. Okay, so this is the pH diagram. First, this is the dome, this is the critical point, this is the saturation line. From the critical line, if you come this in this way, this is saturated vapor and this is saturated liquid. So in the evaporation, first evaporator, the process that is taking place in the evaporator, that is evaporation, the liquid refrigerant is becoming vapor, and then it is compressed in the compressor. This is isentropic, entropy is constant, and here this is the graph for enthalpy. So enthalpy is increasing. Now condensing always occurs at constant pressure, so pressure is constant. Then what? Isenthalpic expansion. Isenthalpic expansion means H is constant, so line will be vertical. So just let me name these points 1 2 3 4. Very simple, but keep one thing in mind, that I have, in this case, I have this is the graph for dry compression. This is the graph for dry compression. Why dry compression? Because the refrigerant that is entering into the compressor, it is in the dry state, it is totally in the vapor state. No water is present. If it would have been wet compression, for wet compression, my pH diagram will be something like this. This is the vapor dome. Wet compression, it would be something like this. because here the 1 2 3 4. So here the refrigerant when entered into the compressor, it is in the liquid plus vapor region. That's why it is known as wet compression. We always favor dry compression. Okay, why? The reason I have told you in my another lecture. Okay, so and next is TS diagram. TS diagram. Okay, still I am telling you that why we favor dry compression. We favor dry compression because in case of reciprocating compressors, if you do wet compression, then the water droplets may damage the piston head. Okay, in TS diagram the graph is like this. This is evaporation, again dry compression because I am here, then compressing. Now I am at this position, that means this is a superheated state. If you start cooling it, the temperature is like this. The first temperature is going on reducing, then the phase change will occur. When phase change will occur, then there is no change in temperature, because we know that when 0 degree 100 degree water is 100 degree water is converting into 100 degree steam. This is an example. This is temperature has not changed, phase has changed. Okay, phase has changed, temperature has not changed. So this is, so cooling or the condensing has started from this point. This is the sensible heat rejection, this is the latent heat rejection, and after this point throttling will occur. Throttling is like this. This is not straight because this is because throttling is isenthalpic. Enthalpy is constant, but here it is entropy. Entropy is not constant, it is always increasing. Okay, so this was your TS diagram. Now with this concept of pH diagram and TS diagram, you will be able to solve any kind of problem. So first take first problem, that is example 3.1, page number 116. This is from the book of R.K. Rajput. Okay, from the book of R.K. Rajput. So this is my problem, first problem. You can see it now. Yes, now you can see it. So let me just read the problem first. A refrigerant plant works between temperature limits of -5 degrees Celsius and 25 degrees Celsius. Temperature limits are -5 degrees Celsius and 25 degrees Celsius. So the lower temperature is evaporated temperature, 25 degrees Celsius is the condenser temperature. The working fluid is ammonia, has a dryness fraction of 0.62 at entry to compressor. This line is very important. I am telling you that when it is entering into the compressor, it is having some dryness fraction of 0.62. So we can get the idea that in this case it is wet compression, not dry compression, because dryness fraction is giving, it is in the liquid first vapor region. Okay, now if the machine has a relative efficiency of 55%, calculate the amount of ice formed during a period of 24 hours. This question is very important. So what they are asking you is that the ice is to be formed at 0 degrees Celsius from water at 15 degrees Celsius, and 6.4 kg of ammonia is circulated per minute. You are keeping a tray of water, suppose, which is at 15 degrees Celsius inside a refrigerator, and they are asking you that if you keep the main switch of the refrigerator on for 24 hours, then how much ice your refrigerator will make from that amount of water that you have kept at 15 degrees Celsius. Very simple, very practical problem. That is, you have kept some water at 15 degrees Celsius, and the question asked is that how much ice is going to form in 24 hours. Okay, so this is the question for asked. So we are let's first draw the pH diagram and the TS diagram. What is the TS diagram? TS diagram, this is the vapor dome. TS diagram will look something like this. First is the evaporation process. It will end here because it is told that dryness fraction, it is told in the question that dryness fraction is 0.62. That means it is not 1. If it would have been 1, then it would be here. Okay, but it is 0.62. That means liquid plus vapor region. That means here. Now it is compressed. Compressed, isentropic compression. Then it is fed into the condenser. Then throttling. So this is 1. This is 2. This is 3. This is 4. Okay. Is this clear or not? The diagram is clear to you. Okay, very good. If the same thing, if I want to represent in pH diagram, then how it will look? See, you can solve with the help of pH as well as TH, anything. Okay, but concept you need to understand. Please note when I'm going to solve the problem, please be very careful. Okay, so it is compression. So it has started from here to here, then here. 1, 2, 3, 4. Okay, first let us find the COP of the refrigerators first. So what is the formula for COP according to this diagram? It is the refrigeration effect divided by work input. Work input means the work done by the compressor. What is refrigeration effect? It is nothing but in this portion, H2 minus H1, divided by what is work input? It is H3 minus H2. So let us find the values of H1, H2 and H3. Then only we will be able to find COP. Now for this particular problem, a chart is provided. If this chart is not provided, you have to search the refrigeration table. Okay, in refrigeration table, do not get confused. Whatever refrigerant it is given, suppose R12, open the page of R12 and you will get same type of charts, but here the refrigerant is NH3. You will see a chart like this. Liquid heat, kilojoule per Kelvin, that means they are talking about enthalpy, that is HF. HF means liquid, at the liquid region, at the saturated liquid, at this region, at this region, okay, and the temperature is 25 degrees Celsius. So 25 degrees Celsius is the upper temperature. In TS diagram I can plot the temperature. So this region is 25 degrees Celsius and this is minus 5 degrees Celsius evaporator. Okay, this is 25, this is minus 5. So so according to my diagram, H4 is given. H4 is given. It is 298.9 kilojoule per kg. Try to see. Once more I am showing you. This is 25 degrees Celsius. Liquid heat, that is HF. HF at 25 degrees Celsius, liquid heat. That means HF is this point. There H4. Okay. H4. Okay. This is given to you 298.9 kilojoule per kg and I have written it. Sorry. Okay, now it is stable. Okay. HF is this. Now, this is given to you latent heat. What is latent heat? It is nothing but the change over heat exchange in this process. Latent heat, that means latent heat is nothing but Hg minus Hf. Hg minus Hf, Hg, this point is G and this is F, that means vapor and liquid. Why this point is representing latent heat? Because latent heat, that means the heat that is rejected or the heat that is gained In case of phase change, here in case of phase change, that means here in the liquid refrigerant is turning from is going to change into vapor. So phase change is taking place, so there is a latent heat transfer. Okay, but in this problem the refrigerant has not totally converted into vapor. It has stopped here. Okay, so Hg minus Hf value is given to you. It is given to you for 25 degrees Celsius it is this much, and for minus 5 degrees Celsius it is this much. That means for 25 degrees Celsius at this point, Hg minus of Hf is given. At this point also Hg minus of Hf is given. We will write down that data when we will require it. Okay, and so H4 is given. So H4 is nothing but it is equals to H1, because if you see the pH diagram, so when you are learning, when you are starting to learn, it's better that draw both the diagrams in your copy, pH and TS. Whenever you feel like, you use that. In this portion of the problem I am using pH diagram. H4 is equals to H1, so it is nothing but equals to 298.9 kilojoule per kg. It is nothing but 298.9 kilojoule per kg. Okay, this is H4 minus H1. Now H4 equals to H1, sorry, and now I know H1. Now I need to find H2 and H3, but this is not so simple, because H2 and H3 are in between these points, in between this dome. It is not in saturated vapor or saturated liquid region. Okay, so we have to use a different concept. Suppose, let's draw the TS diagram again, because I have turned the page. TS. If you understand this problem, next problem we will understand in a very short time. Sorry, I'm starting from here, but in this problem we will start from here. Okay, so this will not be my vapor dome. My vapor dome is something like this, and it will go like this. So it is 1 2 3 4 TS. Okay, so H1 at point 1, so I'm finding out what COP. It is nothing but H1 COP. It is H2 minus H1 divided by H3 minus H2. I know I found out the value of H1. I require H2 and H3. See, H2 is nothing but it is equals to Hg. This, okay, let me write down the temperatures also. This is minus 5 degrees Celsius and this is 25 degrees Celsius. So H2 is nothing but Hg plus X into HFG. Okay, so H2 is nothing but Hg plus X into HFG. Okay, so Hg is what? It is at minus 5 degrees Celsius, and it is H2 is HF plus XHFG. Why HF? Because H2 is what? Try to understand enthalpy at this point plus the enthalpy, change in enthalpy in this zone. This is H2. H2 is here. So H2 is what? Enthalpy at this point plus the change here. So what is the change that has taken place here? So from where did this formula came? If you want to know, I can show you that if this is your G point, suppose this is your F point, suppose HF, this is your HG. Okay, so when you are here, suppose I need to find so when you are here, then what is my enthalpy? It is Hg. That is nothing but the change that has taken place in this zone. Okay, the change that has taken in place in this zone. Okay. But if you are something in between this portion, then if I require to find the enthalpy at this portion, then what is my formula? It is, suppose this is 0.1, then H1 will be what? HF plus the change in this portion, that is nothing but X into Hg minus Hf. What is X? X is nothing but the dryness fraction for this portion. Okay. So H2 is Hf plus X Hfg. This is your formula, and I am putting these values. H2 I need to find out. Hf is what? Enthalpy of this point, because I am at minus 5 degrees Celsius. So from the book, let us see what's the value given. For minus 5 degrees Celsius, HF value is given 158.2. Okay, so it is 158.2, and dryness fraction, it is 0.62. It is also already given. And what is HFG? HFG is what? I have told you, it is nothing but change, Hg minus Hf. It is in the minus 5 degree Celsius region. So it is 1280.8. So it is 1280.8. Okay. So if you solve this equation, you will get H2 as 952.3 kilojoule per kg. Okay, if you solve this, you will get H2 this value. So so for COP I know H1 now, I know H2, I only require to know H3. Okay, now I have to know H3. So how we will find out H3? So try to understand. Now we know we need to find the value of H3. H3 is in this portion. Okay, this is touching. Okay, this is touching the vapor line. Now S3 3 point is this portion. This is also not completely vapor, so there will be some dryness fraction present. There will be some dryness fraction. We need to find out the value of dryness fraction first. How to find out? See, S2 is equals to S3. S2 and S3 are same because entropy is constant, and S2 I know because okay, S2 is nothing but I don't know, required to know the exact value of S2, but we will solve in this way. See, S2 is what? It is SF plus of X into SFG, that is SG minus SF, that is equals to S3. S3 is what? It is SF at 25 degrees Celsius, and this was SF at minus 5 degrees Celsius. Okay, plus this is X minus 5, this is X for 25 degrees Celsius into SFG. Okay, this is also for 25 degrees Celsius, and this is for minus 5 degrees Celsius. Okay, now let's just put the values. SF for minus 5 degrees Celsius is what? It is given. SF for liquid region minus 5 is 0.630. So let me put 0.630 plus X, we know 0.62 because the dry, when we are considering at minus 5 degrees Celsius zone, we are here, and we know the value of x, that is dryness fraction, that is 0.62. It is given in the question, but we don't know the dryness fraction in this region. Dryness fraction here and dryness fraction in this region are different. Okay, we know for here. So what is x? It is 0.62. And what is SFG? That is the SG minus SF. SG minus SF, it is given. Now we have to put the value of SFG. We need to put the value of SFG. So the value of SFG, it is SFG means what? SG minus SF. That is delta S. That is change in entropy. That is delta S. That is nothing but Q by T. We know this formula, and Q is what? Nothing but change in enthalpy. That is whatever it be, Hg minus Hf by T. Okay, Hg minus Hf by T. So at minus 5 degrees Celsius, my Hg minus Hf is given. See, Hg minus Hf is given. So I will use that thing. Okay, it is 1280.8. So it is 1280.8 divided by T is what? Minus 5 degree. So minus 5 plus 273. Why 273 we are doing? Because the entropy value which we have put here, try to understand, 0.630. This is, the value is in kilojoule per kg Kelvin. That's why whenever we are putting the temperature, we have to put it in Kelvin. Okay. So equals to SF at 25 degrees Celsius. What is SF at 25 degrees Celsius? See, 25 degrees Celsius SF, it is entropy of liquid. That means F. F denotes liquid. 1.124. It is 1.124 plus X. I need to find out the dryness fraction at 25 degrees Celsius. I have told you. SFG I know once again in that way. XFG is nothing but Hg minus Hf divided by the corresponding temperature. Here the corresponding temperature is 25 degrees Celsius. So 25 plus 273. So at 25 degrees Celsius, what is my Hg minus Hf? It is 1167.1. It is 1167.1. 1167.1. Okay. So what I have done over here? It is very simple. Okay. Once you understand, it will become very simple. I have done what? I have done S2 equals to S3. We know because it is isentropic compression. I have just put S2 as SF plus X SFG. We know this formula, and S3 also, that SF plus X SFG. These things represent the temperature. This is S3. 3 means 25 degrees Celsius. See, 3 point is what? At 25 degrees Celsius, and 2 point is at minus 5 degrees Celsius. Very simple. So SF at minus 5 degrees Celsius, this thing we have got, and from here the value of X you will get is 0.63. This is 0.63. This value of X you can name as X3 also. Okay, this is 0.63 you are getting. So once you are getting the dryness fraction at this region, you will be able to find H3, which is our main motive. So H3 is nothing but it is HF at which temperature? We know it is 25 degrees Celsius plus the change X3 into HFG at 25 degrees Celsius. So H3 is HF at 25 degrees Celsius is what? This point. So HF at 25 degrees Celsius is nothing but H4. Okay. It is very simple, very simple. Don't worry. So HF is what? The value at 25 degrees Celsius 298.9. So 298.9 plus X3 is what? 0.63. Just now we have found out. And HFG, change. It is at 25 degrees Celsius, change Hg minus Hf. It is 1167.1. It is 1167.1. So H3 you are getting from here is something 1034.17 kilojoule per kg. Now we are ready to find COP. COP is what? It's COP is desired effect, that is nothing but H2 minus H1 divided by desired effect is your refrigeration effect divided by work input. It is nothing but H3 minus H2. If you put the value of H2 that you have found, that is 952.3 kilojoule, 952.3 minus H1, we have found H1 equals to H4. At the beginning we have found it is nothing but 298.9 already given in the question. That is divided by H3 is what? 1034.17 minus of H2. H2 this value only 952.3. Once you put these values you will get your answer as 7.98. This is the COP. But remember, this COP is the theoretical COP. Theoretical COP. This is your theoretical COP, not practical. Why not practical? Because we have considered isentropic compression. Is it possible isentropic compression? Ever possible? Entropy is never constant. Entropy always increases, but we have considered that entropy is constant. So this is theoretical. And in the question they have given a very important data that if the machine has a relative efficiency of 55%, it has got efficiency of 55%. So what will be your actual COP? COP actual will be nothing but theoretical COP 7.98 multiplied with the efficiency they have given 0.55 or 55%. You don't have to remember this formula, I am telling you. You don't have to remember this formula that COP actual is equals to this. No needed. We know that actual COP must be less than theoretical. So 7.98 must be multiplied with 0.55. Okay, so your answer you will get is 4.39. 4.39. This is the COP. But the main answer is what? The main answer we have not found out yet. We require to find out. See, work done so work done is what? It is nothing but H3 minus H2. Work done is nothing but H3 minus H2. What is your H3 value? It is 1034.17 minus of H2 is 952.3. So the result is 81.87 kilojoule per kg. This is kilojoule per kg. Okay. This is kilojoule per kg. If I require to find out, this is the work done. This is kilojoule per kg. Okay. No problem. So what will be my refrigeration effect? The work, it is nothing but the work done 81.87 into COP actual 4.39, because we know that COP is nothing but, I have told you repeated times that COP is nothing but refrigeration effect by work done. So work done multiplied with COP, I will get refrigeration effect. But here I will get the work done in this way. I need to multiply with the actual COP, not the theoretical one. Okay. So what is my refrigeration effect? That is I am getting, just let me calculate it. It is nothing but 81.87 multiplied with 4.39. It is 359.41 kilojoule per kg. This is kilojoule per kg. So if I require to find out in kilojoule per second or kilojoule per second or kilowatt, kilojoule per second means kilowatt, then I have to multiply kilojoule per kg with kg per second. Kg will cancel out and I will be left with kilojoule per second. So what is kg per second? It is mass flow rate, and the mass flow rate is given in the question. See, the mass flow rate is given in the question. Mass flow rate is where the mass flow rate is given. Yes, 6.4 kg of ammonia is circulated per minute. 6.4 kg per minute. Okay, so that means how much kilojoule per kg I have got? Refrigeration effect, how much I have got? It is nothing but 359.41 multiplied with 6.4 divided by 60. So I will get my refrigeration effect as 38.32 kilojoule per second. If you solve this, you will get this 38.32 kilojoule per second. Refrigeration effect. Now the main thing comes. Try to understand. Refrigeration effect is 38.32 kilojoule per second. That means what? That means heat extracted. This is also equals to heat extracted. Okay, heat extracted. Who is taking this heat? The refrigerant, that is ammonia. And who is giving that heat? Water. Water is giving that heat. Try to understand. Water is losing heat. Water is losing heat to form ice. To form ice. Okay. And NH3 or the refrigerant is accepting that heat, and the refrigerant is accepting that heat. Okay, try to understand. You have got this concept. So water was at 15 degrees Celsius. 15 degrees Celsius. So first it will lose heat and it will form water at 0 degrees Celsius, then ice at 0 degrees Celsius. Okay, and who is accepting, who will accept the heat that is lost in this process? That is nothing but the refrigerant is going to accept. So how much heat the water is losing? Just let us calculate. It is nothing but very simple. First 15 degrees Celsius to 0 degrees Celsius of water. So it is nothing but M into Cp. Cp mCp dt, that is dt is 15 minus 0, plus the latent heat in this process, that is m into L, that is m into L is the latent heat, which must be equals to, this is the heat that is water is rejecting to form ice, and who is gaining that heat? Who is actually taking that heat from the water? It is the refrigerant, and we have found that how much heat it is taking. The heat extracted or the refrigerating effect we have found out after such a laborious work is 38.32. The refrigerant is extracting 38.32 kilojoule per second, this much of heat from the water, so that the water can become ice. So this is equals to 38.32. Now we will put the value. Cp is given. Mass we need to find, because in the question they have asked you that how much ice is forming. So amount of water, the mass of water that is melting, same mass of ice is going to form. So Cp is given 4.187. It is given in the question. Multiplied with 15 plus m, we need to find L. Latent heat of ice is what? 335 kilojoule. It is equals to 38.32. This is also in kilojoule per second, so no problem. And if you solve this equation, you will get the value of m as 832. Sorry. Just wait a bit. Let me calculate it to show you. Okay, so it is 4.187 187 into 15, so it is 62.805 m plus 335 into m, that is 335 m is 38.32. So we just solving that equation, m you are getting 0.096. This is kg, this much of kg, this much kg of ice is forming in 1 second. But they have asked you that how much ice is going to form in 1 day or 24 hours. So nothing but we need to 0.096 kg per second, and how much ice is going, this much ice is forming in 1 second. So in 24 hours 0.096 divided by, in 1 hour it is divided by 3600 multiplied with 24. Okay, if you solve this you will get that your answer is 8322.9 kg. 8322.9 kg. Okay, I can show you 0.096 divided by 3600 into 24. It is coming 83229 kg. Okay, sorry, I have done one mistake, very simple mistake. It is 0.096 kg per second. So this is 0.096 into 3600 in 1 hour. In 24 hours it is 24. I have just divided it. Sorry, it would have multiplied. So if you do it, you will get this value. I have found out in my calculator, 8322.79, this much kg. Okay, and in the book the answer is 8322.9. Small difference. Okay, this is your answer. I have understood. I think that you have understand the concept, that how to approach these type of problems. This was very important problem, and it requires a huge concept. And once you are able to understand this problem, you will be able to understand other problems also. And in this video I don't have any more time. I cannot solve one more problem which I wished to solve. In my next video I will solve that another problem.